Well, students, this is a very important class. Today I'm going to discuss about bond polarity. This is a part of age level bonding chapter. I hope you will get very much fun from this chapter and hopefully you will understand it. If you have any confusion, please let me know. Now, let me change the slide at first. Well, at first we need to understand what is electronegativity. Electronegativity is the kind of attraction force by which an atom attracts the pair of electron during covalent bonding. We all know during covalent bonding is formed, we all know that covalent bond is formed due to the share of electron. And a bond pair of electron is formed in the middle of the two between two atoms. By this way, the covalent bond is formed between two atoms by sharing electron. The pair of electrons which is shared that will be attracted by both the atoms. Now, the bond polarity is related with the attraction force. Both the atoms will attract the pair of electron, but here the pair of electron won't be attracted equally. Okay, you may think that the electron pair will be attracted by both the shared atoms equally, but it does not happen in that way. All atoms not don't have the equal tendency of attracting the bond pair of an electron. Considering that matter, it is seen that electronegativity of different atoms are different. So here, Pauli actually discovered the electronegativity of the atoms and he made a scale where he tried to show this kind of bond polarity. In the slide, you can see the bond field polarity of different atoms are shown. Well, we can see here the bond polarity is changing across the period from left to right side, and it is also changing down the group from up to down. The bond polarity is changing. Most electronegative atom in the periodic table is fluorine. It is 4. That means the electronegativity in electronegativity scale jumps from 0 to 4. 0 is the least amount of electronegativity and 4 is the maximum amount of electronegativity. Let me change the slide. Well, and now the question is how the electronegativity will be changed. Actually, if we can consider it is in two ways, across the period from left to right side and down the group from up to bottom. First, let me consider the electronegativity, change of electronegativity across the period from left to right. You can see here the arrows shown, the electronegativity increases across the period from left to right side. That means whenever the element atoms are becoming more non-metallic, it becomes more electronegativity. We can explain it very easily. The electronegativity is the tendency of attracting electron. Now, think how the tendency of attracting electron changes. Attracting electron changes. It changes across the period. The atomic size decreases a bit. As a result, the electron pair will be attracted more by the atoms. As a result, across the period from left to right side, the electronegativity increases. We can also consider the shielding effect. Actually, across the period, the shielding effect remained almost negligible because shell numbers are not changing here. The equal amount of shielding will be available, but number of electron increases, number of proton increases at the same time across the period from left to right side. As a result, as the number of proton increases, it should have more tendency of attracting the shared pair of the electron. So across the period, the electronegativity definitely increases based on the size and based on the nuclear charge. What I have told, I am hopeful that you have understood, and if you do not understand, please let me know. So across the period, due to the size and due to the more nuclear charge is the charge of the proton which is available inside the nucleus of an atom. So as the nuclear charge increases, so electronegativity increases. as the atomic size decreases a bit, so definitely the electronegativity increases across the period from left to right side. Well, now let me consider down the group of how it happens. We will explain it from the next slide. Now, down the group, the electronegativity decreases. The explanations are down the group, atomic radius increases as the shell number increases down the group. So the atomic size increases, so electronegativity decreases. Due to the size of the atom, the distance from the nucleus, center of the nucleus towards the shared pair will be more. As a result, electronegativity will be less. And again, if we consider the shielding effect, more and more shells are adding down the group. As a result, the protons will be more shielded. So due to the more shielding effect, electronegativity will decrease. And here you may raise a question that nuclear charge increases. So why the electronegativity decreases? Although the nuclear charge increases, but it cannot active due to the more shielding effect. Okay, more shielding effect will outweigh the nuclear charge. So although the nuclear charge increases down the group, but electronegativity decreases, it cannot work properly due to the more shielding effect. So down the group, due to more atomic size and more shielding effect, electronegativity will decrease. I hope you have understood the point. Well, so now we can explain how electronegativity increases across the period from left to right side and how electronegativity decreases down the group from up to bottom. Well, let me change the slide now. So we know that sharing of electron between two atoms, whenever the electrons will be shared between two different atoms, their electronegativity will be different. But what will happen if the same identical atom will participate in a covalent bonding, like diatomic molecules O2 or Cl2? Here, if O2 participate in for forming covalent bond between two oxygen atoms, and what will happen due to the regarding the electronegativity? Here, the same atom, as the atoms are same, so there is no electronegativity difference between the two atoms. As a result, the electron density around the shared pair between the two atoms will be uniform. It will be equal. So the shape of the two atoms, will look like the picture in the slide shown. So whenever two identical atoms will participate forming covalent bonding, then definitely the electronegativity of the between the two atoms will be very much, there is no difference between the electronegativity between the two identical atoms. In that case, we will see a very symmetrical shape or around the nucleus of the two atoms. A symmetrical shape of the electron density around the atoms of the two shared pair of the two electron pair of the one electron pair between the two atoms. I hope you understood, guys. So let me change it. And again, but whenever the covalent bond will form between two atoms, then there should have electronegativity difference between, right? Because due to the formation of covalent bond between the two atoms, the shared pair will remain between them in the middle of the two atoms, but the tendency of attracting the shared pair of the electron by the two different atoms will be different, totally different. For example, hydrogen is a comparatively electropositive atom than chlorine. If we see the electronegativity chart, you will see that the electronegativity difference between hydrogen and chlorine will be significant. But chlorine has a much higher tendency of attracting the shared pair of electron. So it will be seen the electronegativity difference between the two atoms will be significant. That means if it is more than 0.5, then it should be a partial hydrogen. All the electron cloud will be attracted towards the chloride, not towards hydrogen. So in that case, hydrogen will be partially positively charged and chlorine will be partially negatively charged. Forming this type of partial positive charge and partial negative charge is called formation of dipole. Whenever dipole will be available in between the covalent bonding of two atoms, then it is called a polar bond. I hope you understood how the polar bonds formed. Now, the polar bonds form whenever the electronegativity difference between two different atoms will be zero point 0.5. In that case, it is significant enough, and as that case, the less electronegative element will be a partially positive charge, and the more electronegative element will be transformed to a partially negative charge. So it, although it is a covalent bonding, but it is a polar bond. It should have polarization, and this type of bonding will show some ionic characteristics. So polar bonds will always show some kind of ionic characteristics, as you will see some positive charge, partial positive charge, and partial negative charge. I hope students you have understood. I will explain it in the later next slide more. So look at the electronegativity in the table. According to Pauli, the electronegativities are like this. Hydrogen is 2.2, fluorine is 4, that is maximum. Fluorine is 3.2, bromine is 3, and iodine is 2.7. So in between, the electronegativity difference between hydrogen and chlorine is 1, which is more than zero point 0.5. So there we must expect significant electronegativity difference between hydrogen and chlorine. So definitely it will be a polar bond where the electronegativity difference is 1. If it is more than zero point 0.5, so definitely it will be a polar bond where hydrogen will be a partially positive charge and chlorine will be a partially negative charge. As a result, whenever bonds will form like hydrogen chloride, we will consider it as a polar bond, and its characteristics will more or less match with ionic compounds. Polar compounds means a bit type of ionic compounds. In case of properties, the nature will be a bit kind of ionic compound type. So here, whenever the compounds will form between hydrogen and halogens, then the electronegativity, due to the electronegativity difference, all this bonding will form covalent bond where, sorry, for polar bond, where hydrogen iodide is the least, have the least polarization, whereas hydrogen fluoride has the maximum polarization. Okay, so hydrogen fluoride will show more pro-ionic characteristics, and hydrogen iodide will show comparatively less ionic characteristics. But it's a fact that hydrogen halides are polar type compound. I hope you understood. Let me change the slide now. So more ionic character means polarization means more ionic characteristics. Whenever we will see by observing the shapes of these molecules during the polarization, during the sharing of electron, we will also explain the polarization. In the first one, you can see these two are two identical atoms where there is actually no polarization difference. So here it will not form a polar molecule, rather it is called a non-polar type of substance, like covalent bonding between two oxygen atom or two hydrogen atom, which electron shapes will be, electron density shapes will be like this. But whenever there will be a polarization difference, like hydrogen polarization between hydrogen and chlorine, we will see a bit distorted shape. The shapes are not, the shape is not uniform like the first one. So by observing the shape of the electron density, we can also understand the second molecule. This contain a bit polarization. That means a bit ionic characteristics. The third one has also a bit ionic characteristic polarization, but fourth one is completely ionic compound, because in ionic compound we know that one atom will completely lose the electron, another atom will completely gain it. So by this process both of them will be converted into a uniform spherical shape, type of spherical shape. So this is considered an ionic compound, the last one. I hope you understood. So here from the first one, that is non-polar, and the last one, that is absolutely ionic compound, and in the middle to this two are polar compound. That means although they are sharing electrons, but due to the electronegativity difference, they will show a bit ionic characteristic. That means they will show a bit polarization. I'm changing the slide, students. But it is very surprising that sometimes in a molecule, bonds are polar, but the molecule is non-polar. If we look at this example between the polarization between carbon and oxygen, carbon-oxygen bond is polar because there are significant electronegativity difference between carbon and oxygen. But both same bond remains in the both side of the carbon atom. And it is they form the bond with each other by 180-degree angle. So whenever they will form bonds like 180-degree angle between the two sides, their polarization will be cancelled out. So by this type of symmetrical, whenever we will see that polar bonds are symmetrically arranged, this is called symmetrical arrangement of the polar bonding. If we see polar bonds are symmetrically arranged, then the overall molecule will be non-polar as the polarization will be cancelled out. But in another case, in water molecule, their shapes are a bit angular. So here it is not one by 180-degree angle. So so the dipole, that means partial positive charge and partial negative charge, won't be cancelled out completely. So that is why it is a polar molecule. Due to the shape, when the shape is symmetrically arranged between the bonding, so then sometimes covalent, if it is asymmetrically arranged, then uh, the polarization won't be cancelled out, and that is why water is a polar molecule. On the other hand, similar type of bonding present, but due to the symmetrical arrangement, carbon dioxide is a non-polar molecule. I hope you understood. This is the end of the topic discussed on polarization, and polar bond exists in bonding, and this is the part of our bonding topics uh, that is part of the bonding chapter in AS level chemistry. I hope you understood, and still you can ask me a question if you have any confusion. Thank you very much.